The first thing that I did was to take the square root of x and write it as x to the 1/2. Then product rule says that it is then 60, that's the constant, times the derivative of the first times the second plus 60 times the first times the derivative of the second. So this then becomes 60 times the derivative of x cubed is 3x squared times x to the 1/2 plus 60 x squared, or x cubed, it should be a cube, times the derivative of x to the 1/2 is 1/2 x to the negative 1/2. First step, we'll leave it for the time being.
So you said there was a reason not to combine the x's?
Yes, because we're practicing product rule, and when we get into chain rule, there's no way you can combine them. So you need to learn the processes on simpler forms of the function, which are our power rule.
That's as far as it needs to go?
For now. Because you're just learning the process. Because we can combine x's, we can factor out a greatest common factor of, it looks like 60, and an x squared, and an x to the negative 1/2 if I want to go that far. But we don't want to go that far. This is not the stuff where this counts. For the second one, I rewrote the x square root of x as x to the 1/2, and I rewrote 1 over x as x to the negative 1. Again, the property of exponents would allow you to bring this together, but we're just learning, the only rule we have now is power rule. And so with power rule, and I could bring these together and just use power rule on one function. But we want to use product rule. So as a result, product rule on this guy right here. So that f prime of x is the derivative of the first times the second plus the first times the derivative of the second. Now when I do a problem, that's what I usually think, but I think in the beginning it's not a bad idea that you write it, and after a while you can drop the notation. The derivative of the first is what? X to the minus 1 is negative 1x to the negative 2 using power rule, times x to the 1/2 plus x to the minus 1 times the derivative of x to the 1/2 is 1/2 x to the negative 1/2. I told you it wouldn't take long to catch on. And that's where we'd stop right now.